Okay, you've now finished something that goes about like this. 22x plus 8 equals 15. You're like, we can solve that. That's not a big problem. You're going to peel off just like an artichoke. Get the x by itself by first getting rid of the positive 8. You do that, well, subtract 8 on both sides. 2x equals 7. So now I have 2 times what equals 7? I don't know. How do we get rid of that 2? Well, it's attached with a multiplication, so we get rid of it with divide. So we have x equals 7 divided by 2. You can leave it as 7 halves or as 3.5, either way. This next section that we're going to talk about is just a little bit different. You have something like this. 2x plus 8 equals, 3x minus 7. Now, we run into a problem here. The major principles that we've been talking about to begin with are that you have the x and you get this x, it's in the center of all these numbers that are piled around it, and you've got to unpeel things. Well, here the x's are in 2 separate places. They're not even together. This is where that power of balancing comes in. You remember this balance thing that we did. Here you have your equation with the equal sign right here in the middle, and it's almost like that's the hinge. And whatever's on this side, you can add, subtract, multiply, or divide anything, so you get the exact same thing on both sides. Well, here, the problem is that, well, we've got a 2x on one side and a 3x on the other, and we want to get rid of one. That's really the biggest question. How do you get rid of one of them? Well, you are all powerful. You can say, I don't like the 2x, so you get rid of it. As long as you do it to the other side, you're safe. So you have a 2 minus the 2x here, minus the 2x on the other side. This is now gone. 3x minus 2x, that's x minus 7. Now the x's are together. They're on one place. They're combined. So you can take this. Okay, now let's peel off what we've got. We've got a minus 7 right here, so let's get rid of the minus 7. Opposite of minus, plus. We have x equals 15. Let's do one more of those. We might need a couple. Let's make something up here. Three x plus 5 in parentheses minus 2 equals a 7x plus 3. Oh boy, we got to get rid of those parentheses. I don't like them. That's a distributive property. Take and jump this 3 in here. We have 3x plus 15 minus 2 equals a 7x plus a 3. Combine what we can combine. We have a 3x. What is that? 15 minus 2 is a plus 13. Equals 7x plus 3. Now again, the two x's you'll see right here, just like we had up in the other problem, are in 2 separate places. And you can't just combine them and make them 10x. They're not together. So we have the 3x here, the 7x there. We've got to get rid of one of them. We don't like them. We've got to put them in the same place. So you can pick. In this case, I don't like that one. So let's get rid of him. And you just subtract 7x. It's like having that balance and just saying, you know what, here we're kind of balanced. Let's take that much off of that side of the balance. Subtract 7x here, and we now have negative 4x plus 13 equals 3. Now that the x is together, we can peel off just like we normally did. Subtract 13 for both sides, and then we divide by a negative 4. We have x equals, 2 negatives cancel, give you 10/4, which reduces to 5 halves. Or if you punch that in your calculator, 2.5. There are a couple of concerns that may arise with this. You can certainly use this anytime you need to move the x's from one side of the equation to the other. But the problem that comes up, I'll show you in this next one. Let's do something like 2x minus 5 plus 3x equals 5x minus 7. Do it the exact same way we've been doing it. Get rid of those parentheses. We have 2x minus 10 plus 3x equals 5x minus 7. We have a 2x and a 3x on this side. We can just put them together. They're 5x. They're both together. 2x and 3x is 5x. Now we see that these x's are in two different places. Let's get rid of one of them. Subtract the 5x, subtract the 5x. We're left with negative 10 equals a negative 7. At this point, the student should pause and reflect, ponder a little bit on what he has just created. When we're going down here, we have an x that we're dealing with, all the way down to we say, oh, x is this number. Here we have just eliminated every single x in the entire problem. It should give you some worry, in fact. We created a statement that says negative 10 equals negative 7. If you use a number line or just do a little bit of counting, you will realize that that is a not true statement. Absolutely false. No matter what x is up here, this is a false statement. It could never be true. In that case, where this one says this thing's going to be true if x equals 2.5, this over here will never be true, no matter what x is. And so it gives rise to the possibility that you might have no solution. There is no number out there that will ever make negative 10 equal negative 7. Right here, there's one number that will work here, and that's 2.5. That's why it's a solution. However, over here, no number will ever work, so we get no solution. By a minor adjustment, a very similar thing will happen with a completely opposite result. So if we did something like 3 with these x minus 5 plus 4x equals 7x, something like that. We're going to do the same thing we did before, jump the 3 in. Now over here we have a 3x, we have a 4x. They can combine. You have a 7x minus a 15, 7x minus 15. And here we have, you should see, something funny's going on. That's exactly what's happening. Something funny is going on. They're the same thing. Continue. In case you didn't see it, go ahead and go down one more step and you subtract the 7x. And they're gone. Gone. You get this statement is always true, no matter what x is up here. Whereas here, when the x's went away, we ended up with a statement that was false. Didn't depend on x, it was just a false statement. This one is true, no matter what x is, and so that means we could stick anything in the world for x. So we can write it like this. X is a very special R, meaning real numbers. They just put 2 lines on it. So when x goes away, if you end up with a false statement, x can't ever work. And if you end up with a true statement, you get x is all real numbers. That's the kind of problem when you have x's on both sides of the equation.